All right, Mr. Ahmed here. Today we're going to work on 10.4, which involves inscribed angles and inscribed polygons. All right, in 10.3 we went over what a central angle was. I'm just going to put a brief little recap over here. A central angle has the vertex in the center of the circle. So this angle, DGF, that is a central angle. And the central angle and its intercepted arc are the same measure. Now today we're going to look at an inscribed angle. They're different. The inscribed angle has the vertex on the circle, okay? And when I look at the inscribed angle, the measure of angle DEF is equal to 1/2 the measure of its intercepted arc. And the intercepted arc is the arc that lies in the interior of the angle. So in this case, DF is the intercepted arc of the angle because it's inside of it. So I just picked some arbitrary numbers. I said DF is 40 degrees. If arc DF is 40 degrees, the inscribed angle is half of that, which is 20 degrees. So central angle and its intercepted arc are the same. Inscribed angle and its intercepted arc are not the same. All right, we got to keep that in mind. The next theorem we're going to talk about is two angles that intercept the same arc. They are congruent. So if I trace angle 1, it sticks out and extend it out, I see it intercepts this arc. I drew some arrows there. And angle 2, when I trace it, it intercepts the same arc. Since those two angles intercept the same arc, they have to be congruent, okay? And our last theorem involves an inscribed quadrilateral. So a four-sided figure. The four-sided figure, all of its vertices are on the circle. That makes it inscribed, all right? If that is the case, the opposite angles have to add up to 180 degrees. So angle A and C, those are opposite. Those add up to 180. And B and D are opposite. Those two add up to 180, okay? So we're going to put these into practice now with some examples. Our first one, always keep in mind, is it a central angle or is it an inscribed angle? And this one, the vertex is on the circle, therefore it's an inscribed. So the measure of the arc, x, and the relationship with its inscribed angle, the angle is half the arc, or vice versa. The arc is twice the angle. So for me to find x, I would just take 2 times 17, which is 34. And I found the measure of the arc, 34 degrees. Now the next one, when I take a look again, I have an inscribed angle. And when I set this equation up, I would say that the angle, 3x, is equal to 1/2 the measure of its intercepted arc, which is 138. Now to solve this one, I can take 1/2 times 138, which is 69. So 3x equals 69, divide by 3, and x is 23. Okay. Now we're back to that little problem here. If you see a bow tie, just like when we saw the bow tie with the alternate interior, if you see a bow tie inside of a circle, odds are you're looking for the same intercepted arc. In this case, angle X intercepts this arc, and 50 also intercepts that arc. Therefore, those two angles are congruent. X is equal to 50. Okay? And another bow tie. Another bow tie. Do they intercept the same arc? Well, this angle intercepts this arc, the big one, and so does that. So these two angles have to be congruent. 80 is equal to 3x plus 5, and now we just need to solve. So 75 equals 3x, x is 25. So that is it for that one. Now, working on this next problem, this one's a big one. So you're probably going to need to write some things down on this. Keep in mind everything we know about triangles, circles, diameters. Lots of information going on here. All right, so let's see what we can come up with. I'm not necessarily going to solve these in the order they're given. And you're going to find the ones I can find first. So the first thing, WX, arc WX is 104. Now the first thing I see with that, if this arc is 104, it also has an inscribed angle. If I trace its inscribed angle, that is angle number 1. So I can find angle 1. Its intercepted arc is 104. For me to find the angle, take 104 divided by 2, which is 52 degrees. So we found angle 1. I'm putting a 52 in, okay? All right, next thing I know is that WZ is 88. So this arc, W to Z, 88 degrees. I put arc measures outside the circle. And again, it has an inscribed angle intercepting that arc, angle 4. So angle 4 is 88 divided by 2, which is 44 degrees. Okay, I'm going to put 44 in. All right, next thing I'm told is ZWY. That's an angle. Angle ZWY. So I'm going to trace it. Z to W to Y. Oh, that's angle 2. Angle 2 is 26 degrees. So that one was given to me. I'm done with that. All right. Let's see here. What are we supposed to find next? So if ZWY is 26, I think that my next best strategy is I see that this shape is a triangle. So I could find the missing angle of the triangle here, and then I would know the vertical angles. I would also know a linear pair. That's an option that I have. Another thing that I'm kind of noticing is angle 6. Angle 6, it also intercepts arc WX. So angle 6 is half of 104. I would just have to take 104 over 2. Which is 52. So 6 and 1 were the same size. All right, now we're going to use that triangle. Let's see, let's find this angle here. 180 minus 52 minus 26 is 102 degrees. So this angle is 102. If that angle is 102, its vertical angle is also 102. Now I could find angle 5, okay? It's not a very good 2. Make that 2 a little better. So these three in the triangle have to add up to 180. So I'll take 180 minus 102 minus 52, and I get 26. So angle 5 is 26 degrees. And lastly, I need to find angle 3. So in a similar manner, linear pair right here, 102. This has to be 78. Those two are linear pairs, so they add up to 180. And now the three angles of the triangle add up to 180, so I would subtract. 180 minus 78 minus 44 is 58 degrees. So I had to use quite a few different things there. I had to use some triangles, had to use some linear pairs, had to use vertical angles, and inscribed angles. So lots of knowledge going into those. A little bit tougher questions. Take your time as you go through them. And moving on. Lastly, we're going to take a look at some inscribed quadrilaterals. Keep in mind, the inscribed quadrilateral, all the vertices are on the circle, so the opposite angles have to add up to 180. So Z plus 80 is equal to 180. So Z is equal to 100. And with our y is opposite 120. So y plus 120 has to equal 180. And y would equal 60. Next one, number 7. We didn't really talk much about the inscribed triangle, but this is an inscribed triangle. Its three vertices are on the circle. Now again, I'm looking and I see a diameter. Diameter cuts a circle in half, so that means this arc is 180. If this arc is 180, well, angle L is the inscribed angle that intercepts that arc. So L has to be half of 180, which is 90. So x is equal to 90. And then to find y, again, the three angles of a triangle have to add up to 180. So we take 180 minus 90 minus 40, which is just 50, not 150. It's just 50. So we found those two angles. And lastly, number 9. This one's kind of tough. So let's take a look at number 9. A couple key things. The first thing we're supposed to find is arc VG. So let's see, V to G. Well, it has an inscribed angle. Its inscribed angle from V to G, I'm going here to here, is 65 degrees. So for me to find VG, the measure of arc VG is equal to 65 times 2, which is 130. So I found that one. All right. Now let's see, how can I find the question mark? The question mark goes from V to F. I do not necessarily see an inscribed angle there. However, I do know V to G, and I also could find V to H. That is a possibility as well. So for me to find, sorry, not V to H, F, V, H, this direction from here to here, its inscribed angle I could locate as an opposite. If I take 180 minus 119, I get 61. So angle G is 61 degrees, therefore its intercepted arc is twice that, which is 122 degrees. So now I kind of have a better idea of what I got going on here. I could find this missing piece, V to H, based off the fact that I know what the entire circle has to add up to. The entire circle has to add up to 360 degrees. So I know that arc GH is 168, and I also know that this arc G to V is 130. So if I take 360 minus 130 minus 168, I get 62. So now I know that VH is 62. And then from here, I know all of these parts, and I could find my missing piece. When I start subtracting here, I end up with 60 degrees. So the question mark is equal to 60 degrees. That one's kind of a challenge problem. I won't give you one quite that hard on your assignment. Have a great rest of the day.